Hello friends, in the previous video we have seen the moment of inertia for C-section. See, already we have completed theory related to moment of inertia, some problems related to the moment of inertia. We have completed L section, T section, symmetrical I section, asymmetrical I section. Now here one more important topic, that is product moment of inertia. See, what is meant by product moment of inertia? Consider an elemental area dA at a distance y and x with respect to x-axis and y-axis respectively. The moment of area about x-axis is equal to, means moment of area about x-axis is equal to y into dA. Now, the moment of YDA about y-axis is equal to x into YD. The term x into y into dA is known as the product of inertia of area dA with respect to x-axis and y-axis. The integral x into y into dA is called the product inertia of the whole area A about x and y axis. The product moment of inertia is denoted by Ixy. See, the formula is Ixy is equal to integration of x into y into dA is equal to x1 into y1 into a1 plus x2 into y2 plus into y2 into a2 plus x3 y3 a3 plus so on. See, again I am repeating this formula. The product of inertia is denoted by Ixy is equal to integration of x into y into dA is nothing but x1 into y1 into a1 plus x2 into y2 into a2 plus x3 into y3 into a3, so on. See, there are some silent features of product moment of inertia. The product of inertia Ixy may be positive, negative, or zero depending on the location area with respect to the axis. The product of inertia is zero if area is symmetrical about one axis or both axes. And one more important thing, the product of inertia about centroidal axis is always zero. So these are the silent features of product of inertia. See, here we have one problem on product of inertia. So you can see this is a Z section. The dimensions are given. Find the product of inertia of the area as shown in figure. So already we have taken L section, T section, I section, C section. Here we have one more section, that is Z section. See, the dimensions are given. As we know, first of all, we have to calculate centroid point. We have to locate the centroid point. So here, for this Z section, you can consider this is the bottom flange, this one is the top flange, and this is your weight. Height is given, that is 22 centimeter. The thickness of the top flange is given 2 centimeter. This distance is given, that is 10 centimeter. Bottom distance is also given 10 centimeter. And this one is 2 centimeter. So web thickness is also 2 centimeter. See, here you can consider three different areas to solve this problem. You can see this. X axis, this one is your y axis, is horizontal axis, and this one is vertical axis. This one is also vertical axis and horizontal axis. This one is a vertical axis and horizontal axis. And here we converted the given Z section into three different areas. We have taken this one as a first area. The top flange is the first area, wave is the second area, and bottom flange as a third area. You can see in this diagram. This one is the top flange. The distances are given. This one is a vertical wave, and this one is the bottom flange. See, for each and everything, for every diagram, you have to calculate x1 and y1 distance. Again, for second, the distance is given, that is x2 and y2. This one is also x2, x3 and y3. See, this is your x3 distance. That is very important. So for every area, you have to calculate x distance from vertical axis. Here, from this vertical axis to this horizontal distance, that is x1 mentioned here. In this diagram, from vertical axis of a diagram, the distance is x2. You can see this. Means y-axis to this centroid point distance, that is x2. And here, from this y-axis, the distance is x3. This distance is x3. This is your x3. For the first diagram, this is your y1 distance. The distance from x-axis, horizontal axis, that is y1, shown in this diagram. This one is a y2 from x-axis, and this distance is y3. Already we studied in the Centroid chapter in the engineering mechanics. So here, now we have all the distances, x1, x2, and x3. We have the area of A1, A2, and A3, the dimensions for first rectangle, second rectangle, and third rectangle. Accordingly, we have to calculate the centroid. So we know that area 1 is equal to B1 into D1. We have the values 10 into 2, that is 20 centimeter. We know that x1 is equal to b1 by 2, that is 10 by 2 is equal to 5 centimeter. See, while solving problem, you have to refer e-content also. While listening this video, you have to refer e-content. It will be more useful. It will be more understanding. See, y1 is equal to d1 by 2 plus 20, that is 21 centimeter. For 2, for rectangle 2, that is A2, X2, and Y2. Similarly, we have to take A2 is equal to B2 into D2. The answer is 36 centimeters square. Base is 2 into depth is 18. X2 is equal to 10 minus B2 by 2, that is 9 centimeter. Y2 is equal to 2 plus D2 by 2, that is 2 plus 18 by 2, that is 11 centimeter. For third rectangle, A3 is equal to B3 into D3. So 10 into 2 is equal to 20 centimeter. X3 is equal to 8 plus 10 by 2, that is 13 centimeter. And Y3 is equal to D3 by 2 is equal to 2 by 2 is equal to 1 centimeter. See here, what I am explaining, that is very, very important. This one is the first rectangle. The dimensions are given, that is 10. This one is 2. Here the base is given, that is 2 centimeter. Height is given, that is 18. Here base is 10 centimeter. Depth is given, that is 2 centimeter. See, x1 and y1 distances are given. You have to take a1, a2, a3, x1, x2, x3, y1, y2, and y3. And now, according to the formula, we know that Ixy is equal to a1 into x1 into y1 plus a2 into x2 into y2 plus a3 into x3 into y3. We have the value of a1, x1, and y1. We have the value of a2, x2, and y2. Here we have the value of a3, x3, and y3. Whenever you will put all the values, you will get the answer. Here a1 is equal to 20, x1 is equal to 5, y1 is equal to 21. Y2 for a2, the answer is 36, x2 is 9, and y2 is 11. A3 is 20, x3 is 13, and y3 is equal to 1. So after putting the values, you will get the product of inertia, that is Ixy, that is 5924 centimeter raised to 4. See, the unit is also important. This is the product moment of inertia, and the unit is 5009 unit is centimeter raised to 4, and the value is 5924, 5924. See, now I have completed product moment of inertia. In the next video, we will see some important problems related to the entire chapter, that is moment of inertia. Thank you. Thank you very much.